Okay, for page, I know that says 16. Jiminy Christmas, where was my brain? For page 6. I'm only doing one example. The first example is just a greatest integer again. And the only thing different about number 18 is it puts the absolute value in the denominator. It doesn't change the -1 and 1 answers that you get. So for this first one, I'm going to have array because there's only one inequality symbol. It is heading downhill because of the slope. It's array left and it's closed. For the one at the very bottom, it's also array. And it's also array where we have negative slopes, so I draw the negative slope. I want the right side of it because it's moving right. And so I put the arrow there, and I do not see an equal, so I'm going to put an open circle. For the one in the middle, it's just a segment, and it has positive slope. The left end does not include the ordered pair, but the right end does. So I now know what my picture is going to look like. I'm going to have this shape over here somewhere on the line, -1. I'm going to have this other shape that looks like this going up and down somewhere in here between -1 and 3. And then at 3 and on down, I'm going to have a shape that goes down something like this. So let's go for it. So doing the very first one, since I know that the slope is -1, but I want to go left. And since I want to go left, I'm going to negate the numerator and denominator. So I'm going to plot my -1, substituting 3 minus a negative is 3 plus 1 is 4. So I'm going to plot my -1, 2, 3, 4 with a nice solid dot. And now I want to go up 1, left 1. So I'm going to go up 1, left 1, up 1, left 1. And I could stop there, and I'm going to be lazy and just stop and do a couple points and put the arrow. Now I'm ready for the one in the middle. For the one in the middle, when I insert -1 plus 3, I get 3, but I don't want that ordered pair. I insert 3, and 3 plus 4 gives me 7, and I want to close that one. So I find -1, 3, and that's an open circle. And then I plot 3, 7, 1, 2, 3, 4, 5, 6, 7. And then I just connect the dots, just like you were in kindergarten or preschool. Connect the dots. And then to do the last one, it's array again, going right. I insert 3, 2 minus 6 is -4. It's not included. It's not closed. So 3, 1, 2, 3, 4. I put an open circle there. I could do another point, but I'm going to use slope. And since it's going right, I don't need to negate. I'm just going to go down to right 1, down to right 1, and I can draw it, and I can put arrows on it or leave it undone. And this is my cute little picture. You know, I mean, such is life, folks. What you see is what you get. So now, when I am approaching -1 from the left, analytically, 3 minus x is still 4. When I approach -1 from the right, I'm using x plus 4, and I get 3. I see that these are not equal, so D and E, and I know it's a jump. The function value belonged in the top one, so these match, and notice there is the closed dot, so it matches what's going on. When I approach 3 from the left, it's going to be the middle one. And so I get my, I'm supposed to say, yeah, 3 from the left, sorry. I get my, whatever I want to say, 7. Trying to get the word out of my mouth is horrible. And when I approach from the right, I inserted it in here, and 2 minus 6 gave me the -4. Again, these were not equal. They were both real numbers, so I know it's a jump. And the equal to was in the middle one, so it's going to match my green answer. So I did it both analytically and I did it graphically. Let's look at the graph. As I approach -1 from the left, I'm indeed, my y value is 4. As I approach from the right, my y value is 3. When I move to the number 3, when I approach from the left, I'm going to end up being +7. But when I approach from the right, I'm going to end up being -4. So, only video that you need for this segment.